Okay, so let's take a look at problems 7 and 8. All right, let's see if I've got this thing focused in here. Okay. So again, I probably personally would not look at this as a quotient. I think I personally would rather look at that as 5 times the derivative of f of x to the minus 1 power. Now, if I did it that way, of course, I could do it the other way as well, but I'd have a negative 5 f of x to the minus 2 times f prime of x. And so if we thought of it in that way, of course, f of x at 4, f of 4 is negative 6, right? And then negative 6 squared is 36. That's going to go in the bottom. And then I need to multiply that by f prime of 4. And f prime of 4 is root 2. And so I guess that's my answer right there. This one I'll go ahead and do it the quotient rule version, and we're just going to do our low d high minus high d low. Let's hold that down. And we're going to square what's below. And some of you probably could just write that down as you go, but I feel a lot safer if I just come in here and substitute one piece at a time. So g of 4, we're looking at 1. F prime of 4, we're looking at root 2. F of 4, again, we're looking at negative 6. And g prime of 4 would be e, and last g of 4 itself would be 1. So we're looking at root 2 plus 6e all over 1. So it looks like we're kind of done right there. Sorry, I didn't have that up high enough. Okay, now we got a little chain rule going on. G times f would be g prime of f times f prime. And of course, if we're plugging in, I'm assuming everything here is the number 4. It actually doesn't say that, but I'm pretty sure that's the intent here. So f of 4, of course, we know to be negative 6. So that is going to turn into g prime of 6. F prime of 4 is root 2, and g prime of 6 is looking at, I believe it's negative 5. And so that's the end of letter C. Here we're going to have the derivative of the outside times the derivative of the inside. So, of course, f of 4 itself is, again, negative 6. F prime of 4 is root 2. But this is the first time we're using f prime of negative 6, and f prime of negative 6 looks like 6. So we are good to go on that one. All right, let's move on a little bit further. Now, go ahead and change the angle on my camera here so I can see a little bit more of my screen. This is actually asking me to take the second derivative and then evaluate that second derivative at the number 6. So we're going to start off by thinking about this as x plus 2 to the 1/3 power. So if I was going to take my first derivative according to the chain rule, we would have this. And I did say I'm not going to really stress the chain rule on the test, and I'm not, because really the derivative of what's inside is simply 1. So this is dy dx right here. So if we were then going to take the derivative of this, that would be d squared y dx squared is how we symbolize that. We take the derivative of the outside, which would be negative 2/9 x plus 2 to the negative 5/3. And that actually kind of is it. We're kind of done with that. And we're going to find the equation of the tangent at x equals 6 and f double prime of 6. So a couple little things going on. So we found a. We found d squared y dx squared. I'm going to actually jump in here and do what I'm going to call part C and find f double prime of 6. So if I plug in f double prime of 6, that's negative 2/9. 6 plus 2, of course, is 8. Now, of course, we want to remember that 8 to the 1/3 is actually 2. If I rewrote it, oops, this is a 9, shoot, negative 2/9. If I wrote it this way, in some ways that's a little bit nicer because 8 to the 1/3 is exactly 2. 2 to the 5th power is 32, but that's in the denominator. And so I end up with a number of, that's interesting, I'm actually getting a slightly different answer than what I got when I did this problem earlier. 270, 200, what is that? Oh, no, it's not. 288 or -1/144. That does match what I had previously. Now, as far as finding the equation of the tangent at x equals 6, the first thing I need to know is what happens at x equals 6. So what was the point at x equals 6? So if I plug 6 into the original problem, of course, 6 plus 2 is 8. The cube root of 8 is 2. So I've got the coordinate 6, 2. So we've got this, that, and now I need to find the equation of the slope of the tangent. So our slope is going to be f prime of 6, not f double prime, but just f prime of 6. So if I were plugging 6 in right here, let's see, that would be 1/3 of 8 to the -2/3 power. Of course, just like we saw down here, the cube root of 8 would be 2. 2 to the 2nd power is 4. So this is 1/4 times 1/3 is 1/12. So it looks to me like we have a slope of that tangent line being 1/12. All right, and let's see if we can go ahead and squeeze in one more before I stop this particular video, taking a look at number 9. At what point does the slope at what point does the function have a slope of -11? So of course, slope comes straight off of g prime. So if we take our derivative, this is a quick and simple, this would be 2x squared plus 8x minus 5. We want to know where is this value right here equal to -11. So if I add 11 to both sides, we get 6. In this particular instance, what I noticed is pretty quickly I could divide everything by 2. And this problem is pretty clearly rigged up to be pretty nice because to get a product of 3 and a sum of 4, it would be a 3 and a 1. And as always, if you have something that is not set equal to 0 that's a quadratic, we make it set equal to 0 by moving things across. And we found that x equals -3 would make that work, and x equals -1 would make that work. Now keep in mind, that's actually not what the question says. It doesn't say give the x values, it says the points, and those points are actually points on the original curve. So I think I need to take the original equation. Just takes a second to type that in, right? 2/3 x cubed plus 4x squared minus 5x plus 1. And as we have done a lot, let's do vars, y vars. Let's let the calculator evaluate that at -3. And I found out that that was the value 34. And last, if we evaluate that at -1, we're looking at, that's going to be obviously a fraction. So we're going to have 28/3 was my secondary value. And that gives me those two values that has a slope of -11. All right, so that does it. We just have a couple of problems left to go. We'll catch that on the last video. I'll see you back next time.